Another example which we used to actually take our students to look at when we went on field courses to Glasgow as part of national and regional spatial planning. You went to Liverpool last year, didn't you? A few years ago we used to go to Glasgow and Edinburgh, and one of the things we looked at was the Ravenscraig steelworks site just to the south of Glasgow, which closed in 1992 with the loss of over 2,000 jobs. And you can imagine that the urban regeneration organisations in that area are very keen to get that site redeveloped, to regenerate the area and to bring in investment into Ravenscraig. It's a very large site, 450 hectares, pockets of severe contamination. This was the site which I mentioned to you when we were talking about site appraisal, where they had to move the newts, the 4 or 5 greater crested newts, at a cost of about, what did we say, £200,000 was it, to move those newts. So heavy contamination over parts of the site, and what they did was, for the worst of it, they essentially put the heavy metal contamination, it was mercury and lead and so on, into heavy membrane bags, large heavy plastic bags, if you like, and rather than removing them somewhere else, remember that's very expensive, what they did was they piled them into a hill, into a large hill, covered it with topsoil, rather ironically called it Prospect Hill, and it's in use as an open space. So if we look at the master plan for this new town which they're proposing at Ravenscraig, you can see all sorts of different uses there: schools, housing, town centre, college and so on. You can guess that this is Prospect Hill here, and that is made up of several thousand large plastic bags, probably about the quarter of the size of this room, piled up with the most serious contaminants within it. And protected as open space. That will not be built on. That's become a landscape feature on the site, and was seen as a less expensive way of cleaning up that land rather than dig and dump or any other of those remediation techniques we looked at. So that's quite an innovative idea, isn't it? Keep it on site, bag it up, seal the bags so that they can't leak into the surrounding watercourses or the surrounding soil, and use it as a landscape feature. So you don't have the risk of building on top of it as you did at Bryn Mawr. Cost of that was round about £24 million to remediate that site. Again, heavy subsidy, because this is an area now of severe high unemployment and social deprivation. This investment they've been trying to regenerate this site since the mid-90s, and I think they've now started on some of these housing areas over here as the first phase of it. And of course, not the best timing for a major regeneration project in what's essentially a fairly low demand area. But that's an interesting example of a rather innovative approach to remediation. And the third example I want to show you is of Wimpey Homes in North Cardiff, who wisely or unwisely, you might have your own views on this, swapped a piece of land with another house builder in Cardiff, and it was a proposal for 32 new houses, but it was poor ground. It was not a very good subsoil, and the necessity was to create sufficient foundations for these houses that they had to pile the foundations to an average depth of 18 metres. Now, that's pretty deep piling, isn't it? In fact, that's very deep piling, and it's very expensive to do. But that was the only way they could provide safe foundations for these new homes. During the piling operations, they knew there was potential for contamination on the site, for methane and radon. And so while they were doing these piling operations, they were monitoring, or the Environment Agency was monitoring whether there were any contaminants or pollutants on the site. And they found a pocket of radon gas during the early stages of the piling. And when that happens, the developer then has to take steps to make sure that those houses are going to be safe to live in. So if you go back to your construction lectures in the first year, you will recall that those sorts of foundations might be a very typical traditional house foundations, yes? That's what you might expect to see. And there's a typical strip foundation with a block cavity wall below the ground. And most houses, all these new houses being built out here by Redrow and the other housing developers here, will have those kinds of foundations, which are fairly easy to construct. They're not very expensive, and would very typically form safe foundations for the design life of those houses. What they had to do on this site, on this Wimpey site, was to use a pile driver. You can see the pile driver there at the top. And they had to provide these 18-metre driven piles through this filled land. And if you look at the scale of that, it's pretty significant, isn't it, in terms of the depth, the extra cost, and the significance of those piles. So that was the first extra cost as a result of the poor ground conditions that they were building on. The second big extra cost was because of this gas, or this potential gas, that they found in pockets underneath one of these houses when they were piling the new houses. So there we have the pile drives. I'm sorry, that's not a very clear image, but driving those piles into the ground, and there's an illustration of the sort of equipment and machinery that they were using to do that. So as a result of the gas, the company then had to take action. They couldn't ignore the fact that this gas had been found. So not only were the foundations slightly unusual, but they had to change the design of the slabs that the houses are built up from to beam and block as suspended slabs, and they had to put telescopic vents into them to help with ventilation, to avoid any build-up of gases in the foundations of the houses. Part of that also included a layer of specialist methane and radon geotextile barrier. So a new geotextile barrier was put into those foundations to stop any gas getting inside the buildings. So if you look at how that might have worked, you can see the green line there is the barrier to prevent the gas coming up, and then the ventilation comes in at the side to ventilate that void under the beam and block floor. So quite significant changes to the design of the foundations, extra costs, extra time in construction, extra specialist skills required to make those foundations safe and to prevent any gas coming into those buildings.